GATE 2019 Metallurgical Engineering Question 30. In a typical scanning electron microscope image, the information about topography and atomic contrast are obtained from, we have four options: secondary electrons and auger electrons, primary electrons, secondary electrons and backscattered electrons and auger electrons. Fine. So first of all, let us look at the electron specimen interactions. So when the high energy electron beam strike a specimen, the electrons are scattered by atoms of the specimen. Now, as shown in the figure, the interaction between the electrons and the specimen atoms occur within a certain volume under the specimen surface. Okay. This zone is usually described as pear-shaped, and its size increases with the energy of incident electrons in the probe. Okay. So this is electron probe. Now, besides secondary electrons and backscattered electrons, characteristic X-rays are also produced in this interaction zone, and these are useful for chemical analysis. Now in the question, we are asked which kind of electrons will provide us the topographic contrast and which kind of electrons are going to provide us the atomic contrast. Now let's look at the atomic contrast first. The atomic contrast is also known as compositional contrast, and it refers to the variation in the gray levels in an SEM image that corresponds to the variation in the chemical composition in a specimen. So the origin of this compositional contrast, it arises because of the capability of backscattered electrons to escape from the specimen that depends on the atomic number of the specimen atoms. Okay, and the property that characterizes such capability is known as backscatter coefficient. The backscatter coefficient is a ratio of number of backscattered electrons that are escaping from the specimen to the number of incident electrons. So if more number of backscatter electrons are escaping from the surface, the coefficient will be higher, and its value varies from 0 to 1. Now it has been observed that the value of coefficient, it increases with the atomic number. So in any area in a specimen that contains chemical elements with the higher atomic number will generate more backscatter electrons, and the difference in the number of backscatter electrons collected by a detector will appear in the difference in the gray levels in black and white image. That is, the area with atoms of higher atomic number is going to appear brighter, because higher the atomic number, more will be the number of backscatter electrons that are being produced. This image illustrates the effect of atomic number on the interaction volume of a specimen. So if you look closely, the material with lower atomic number have a higher interaction volume, because the primary electrons are going to penetrate deeper because of lower interference from the low atomic number nucleus. While on the other hand, the material with higher atomic number, the elastic scattering is going to be higher because of larger size of the nucleus, heavier nucleus, and thus the backscatter electron yield will be higher in case of higher atomic number. Therefore, larger the yield, more the number of backscatter electrons will be detected by the detector, okay, that are emitting by a higher atomic number element. So that element will appear brighter, while a lower atomic number element will appear darker because the backscatter electron yield will be smaller for lower atomic number element. So this variation in the gray levels in a black and white image leads to the formation of atomic contrast, and backscatter electrons are responsible for generating the compositional or atomic contrast. Next, let us talk about the topographic contrast. The topographic contrast in SEM, it refers to the variation in the signal level that corresponds to the variation in the geometric feature on the specimen surface. And this topographic contrast occurs because of two effects: the trajectory effect and the electron number effect. This trajectory effect, it arises from the variation in how the specimen surface is oriented with respect to the detector. That means the electrons which are emitted from a specimen surface which is facing the detector will be collected abundantly, and the corresponding sites in the image, they will appear brighter. On the other hand, the electrons which are emitted from the surface which is not facing the detector will reach the detector with difficulty, and hence the corresponding sites in the image will appear darker. Okay, this is shown in this particular image. This is the trajectory effect. So surface B, surface D, they are facing the detector, so the electrons which are emitted from these surfaces will be collected by the detector easily, while on the other hand, surface A and C which are facing away from the detector, the electrons which will emit from these surfaces will appear darker because electrons will have a difficulty reaching the detector. The next effect is the electron number effect. Okay, the electron number effect. Now what do we mean by electron number effect? It means that when electron probe hits a surface at an angle, more electrons can escape from the specimen than when the probe hits the flat surface directly, as can be seen. So here the fewer electrons are escaping from the surface as compared to when the electron beam is hitting the surface at an angle, like in these two cases. Hence, due to this effect, there are certain areas of the specimen, like edges of a spherical particle, the raised areas or the cavities, they will appear brighter as compared to the flat surfaces. And the secondary electrons are the primary signals that are used to generate the topographic contrast, because they are generated at a depth of around 5 to 50 nanometer. Okay, so the yield of secondary electron depends heavily on the surface topography, fine. While on the other hand, the backscatter electrons, they escape from a depth of around 50 to 300 nanometer. Since backscatter electrons are the product of elastic scattering, so they have energy level very close to the incident electrons, and due to this reason their high energy enables them to escape from the much deeper level in the interaction zone, okay, which varies from 50 to 300 nanometer. While the secondary electrons are the product of inelastic scattering, and they have a energy level of some kilo electron volts, and they can escape only from the volume near the specimen surface. Okay, So topographic contrast, we use secondary electrons signals. For atomic contrast, we use backscatter electrons. Okay. So correct option is option C. Take a look at the two images. Here you can see the topographic contrast. This is image produced using secondary electron signals. So here both the trajectory effect and the electron number effect comes into play. And that's why you can see the contrast generation. Some areas appear brighter because they are oriented towards the detector, or more number of electrons are generated through those surfaces. And this is a backscattered image. Here you can see the compositional contrast. 1, 2, 3, 4. These are different elements. The brightest one corresponds to the element having the highest atomic number. One corresponds to element with lowest atomic number, and it has very smaller backscatter electron yield. Due to that, the image appears darker. Hence, to know more about the compositional contrast and the topographic contrast, kindly refer lecture 14, Fundamentals of Optical and Scanning Electron Microscopy, Dr. S. Sankaran, Department of Metallurgical and Materials Engineering, IIT Madras. Thank you.